Here we have AP calculus AB problem. Okay, let's go to the information. Find the equations for the lines that are tangent and normal to the curve y equals to square root of 2 times cosine x at the point pi over 4 comma 1. Okay, so we have to find the equations of the lines that are tangent and normal. Okay, first let's find the equation of tangent line. Let me write the stuff over here. Equation of tangent line. So there is a formula to get the equation of a tangent line. That is y negative y1 equals to m times x negative x1. So here x1 comma y1 represents the point at where we draw the tangent line to the given curve, and also this m represents the slope of the tangent line. Okay, the point x1 comma y1 is given over here. That is pi over 4 comma 1. Let me write over here pi over 4 comma 1. So we can plug in pi over 4 for x1 over here and 1 for y1 over here, but we need the slope of the tangent line m. So what do we have to do for that? To get the slope of the tangent line, what I have to do is I have to find dy over dx from the given function. That is, I have to find the first derivative with respect to x from the given function. Let me write the given function as it is. It is y equals to square root of 2 times cosine x. Okay, let me find derivative on both sides with respect to x. When I find derivative of this y with respect to x, I am getting dy over dx equals to, so here the cosine x contains a variable x and it is a constant multiplied by the variable. So when I find derivative, if there is a constant multiplied by the variable, I have to keep the constant square root of 2 as it is. When I find derivative of this cosine x, it will be negative sine x. So then I'm getting a square root of 2 times negative sine x will become negative square root of 2 times sine x. Okay, now I got the slope of the tangent line, that is dy over dx, but I have to find the slope of the tangent line at the particular point pi over 4 comma 1. So for that, what I have to do is I have to plug in this point pi over 4 comma 1 into the result of dy over dx. When I look at the result of dy over dx, that is negative square root of 2 times sin x, I find only the variable x, so I don't find variable y. So now what I have to do is to get the slope of the tangent line at this point, I have to plug in this x coordinate pi over 4 for this x over here. So to get the slope of the tangent line. Okay, so we know that m represents the slope of the tangent line. So to get the slope of the tangent line at this point, what I have to do is I have to, let me write it, square root of negative square root of 2 times sine. So I have to plug in this point, that is the x coordinate pi over 4 for x over here. Let me do it. In case if there is any y over here, I have to plug in this y coordinate 1 for that y, but we don't find y. Okay, then m equals to negative square root of 2 times. So sine pi over 4, actually it's a 45 degree. So we'll be able to get the value of this sine 45 degree either from trigonometric ratio table or unit circle. So the value of sine pi over 4 is square root of 2 over 2. Then I'm getting m equals to negative. When I multiply square root of 2 and square root of 2, it will just become 2 divided by 2. Finally, I'm getting m equals to negative 1. So that is the slope of the tangent line is negative 1. Okay, now what I have to do is I have to plug in the results, I mean the point pi over 4 comma 1 and negative 1 over here into the equation of the tangent line. Then I'm getting y negative. So for y1, we have to plug in 1 equals to the value of m is negative 1 times x negative x1 is pi over 4. Okay, now I got the equation of the line which is tangent to the curve y equals to square root of 2 times cosine x at the point pi over 4 comma 1. Okay, now what I have to do is I have to find the equation of normal line. First, let me write the formula for equation of normal line. Let me write it over here, equation of normal line. Okay, the formula is almost the same formula, y negative y1 equals to, so to get the equation of normal line, we have to replace the slope of the tangent line m by negative 1 over m. So when you find the equation of tangent line, you use m as a slope of the tangent line. But when you go to the normal line, so to get the slope of the normal line, I have to take reciprocal of the slope of tangent line, and also we have to take negative sign over here times x negative x1. So here the same point x1 comma y1, because we find both tangent and normal at the same point pi over 4 comma 1. So for x1 comma y1, we have to plug in pi over 4 comma 1. And already we got the value of m, which is negative 1. Actually, this is a slope of the tangent line. So, but we are not using, we are not going to use this value m directly over here. So, because we just replaced the m by negative 1 over m. So, this is the slope of the normal line. Okay, now what I have to do is I have to plug in the results of what I got over here. That is, y negative. So, for y1, I have to plug in 1 and negative 1 over. So, the value of m is negative 1. Times x negative x1 is pi over 4. So this negative will cancel. I'm getting y negative 1 is equal to 1 times x negative pi over 4. So this is the equation of the line which is normal to the curve y equals to square root of 2 times cosine x at the point pi over 4 comma 1.